Acetic anhydride is a very strong acetylating agent, which is commonly used to make esters and also some illegal drugs. I, however, am going to be making it to use to synthesize aspirin from scratch in a future video. To make the acetic anhydride, the first step is to add 100 grams of sodium acetate into a round bottom flask. It's extremely important that the sodium acetate is anhydrous and not the trihydrate. Any water here will destroy the acetic anhydride. I also added a gas adapter and a hose that led to outside the window to avoid breathing in any vapors. I then needed to measure out 90 milliliters of acetyl chloride. It's extremely important to use a respirator when handling acetyl chloride. This is because acetyl chloride is very toxic and it reacts with the moisture to form HCl gas, which is also corrosive. I then added 90 milliliters of the acetyl chloride to the addition funnel on top. I also set up an ice bath under the round bottom flask because the reaction is very exothermic and our acetyl chloride will boil off if we don't keep everything cold. We now slowly open the valve and allow the acetyl chloride to drip in drop by drop. This causes the acetyl chloride to react with the sodium acetate, forming acetic anhydride and sodium chloride. I occasionally took off the gas adapter to stir things around with a thermometer so I could also monitor the temperature. Even with the ice bath, the temperature even got up to around 80 C, which is not good. It is recommended to not let the temperature go above 50 C, which is the boiling point of acetyl chloride. If the temperature does go above 50 C, the acetyl chloride will boil off before it has time to react with the acetate. Eventually, all the acetyl chloride had been dripped into the round bottom flask, and at this point I closed the valve. Unfortunately, the acetic anhydride vapors had destroyed my thermometer and got rid of the markings, making it useless. But oh well. Anyways, I now took off the addition funnel, and it's now time to distill off the acetic anhydride. To do this, I set up a distillation apparatus and turn on the heating mantle. Acetic anhydride boils at around 140 C, so we need to raise the temperature to at least 150. Eventually, we started collecting some crystal clear distillate. The temperature on the thermometer was only 100 C, so this is just water. The temperature eventually rose to around 117 C. This corresponds to the boiling point of glacial acetic acid. It turns out my sodium acetate was not completely anhydrous, so some of the water in it reacted with the acetic anhydride and made acetic acid, which was now boiling off. Eventually, the temperature got to around 140 C, so we're now collecting acetic anhydride. So I emptied out the collection flask and got rid of the water and acetic acid. So I kept collecting the acetic anhydride until the flask filled up. At this point there was no more space, so I had to empty it out into a bottle. Once no more acetic anhydride was boiling off, I emptied out my collection flask into the bottle as well. And there we go, we've now made some pretty pure acetic anhydride. If you want to use this for like syntheses and for some more analytical purposes, I recommend distilling this at least 2 more times, but it's good enough for what I need. The final yield of acetic anhydride was 92 milliliters, which corresponds to a yield of around 81%. In the distillation flask, I was left with a big blob of solid sodium chloride. This can be cleaned up by just boiling water in it. I hope you guys found this useful, and I'll see you in the next video where I make aspirin from scratch.